Hello, welcome to Econometrics with Melody. In this video, we will cover some of the useful topics related with probability and statistics. Actually, we're running a probability and statistics series. This is the first video, and we are going to cover some of the important topics related with descriptive statistics. And first of all, we are going to deal with a mean. And whenever we talk about some of the important characteristics of population, we call them as parameter in statistics. And then when we talk the counterparts about the sample, then we call them as statistics. Statistics. Now, for the population, how do we calculate the mean? And this is a measure of central tendency, a descriptive statistics, we know that. And for population, we measure it by mu. And the average or mean is actually the sum of all the observations. And we are going to take the entire population and observations, and we divide it by n. So in sigma notation, this is equivalent to summation x divided by n, where n is the population size. Now let us calculate the counterpart for the sample, and we'll be focusing about the sample. So the mean is represented by x bar, and we have similar explanation. We take the sum of all the observations that we have in the sample, and we have n number of observations in the sample, and we divide it by n, and this is what we get is in sigma notation summation. Let me write it as summation x I, and I is equals to 1 to n. We are adding all the ith observations up to n, and we are going to divide it by n. Similarly, we could have written it as I is equals to 1 all the way to n, and xi. So this is very simple. Now let us treat when the observations are provided in terms of their frequency. And how do we calculate the mean? This is again very simple. F1 x1 plus f2 x2, the product of the observation and its frequency, all the way to fn xn divided by the sum of the frequency. So this is equals to summation of fi. Let me write it in terms of ith notation, fi xi divided by summation of fi, where I is equals to 1 to n, and here is where I equals to 1 to n. And this can be further written as summation I equals to 1 to n and fi xi, and where summation of all the frequencies that should give us the sample size. This is again very simple. Now let us try to find the mean. What is the formula to calculate the mean when the probability is given? PROBABI probability. So in case of probability, we call the mean is expected value or expected value. So it is expected value of x, and this is equals to probability p1 x1, the probability of first observation, plus probability of second observation. We take the product of the observation along with its probability, and all the way to probability of, let me call it n and xn. And this in sigma notation, this is equals to summation I is equals to 1 to n, and it is p I and x I, where we should see that probability of I is equals to 1 to n, and probability of I, one of all the probability that should be equal to 1. This is the basics of the probability. And the fifth one, let us say when we know when the variable is a continuous variable. So in case of continuous, continuous, again, let us write it as x bar, or we can write it as expected x as well, or we can write it as expectation of x. This is equals to, we integrate it from lower bound to upper bound, and then x function of x, this gives us the probability and change of x. So let me write it in terms of probabilities in this notation, where this is equivalent to integration is equivalent to summation. X is the variable itself, and f of x, this is going to give us this is equivalent to the probability. So this is the case. So I equals to 1 to n. So this is a kind of tentative indication or the equivalent indication. Now let us see how to calculate the probability, how to calculate the mean, or how to represent the mean using matrix notation. So in matrix notation, this is equals to I transpose X divided by I transpose I, where X is the vector of observation actually, or variable, vector X, and I is also a vector with ones in its element. So I is equals to, let me take an example with only 3 observations. If there are n number of observations, so I should contain n number of ones, its elements. Now let us see. First of all, let me explain I transpose I, that should give us a sample size. I transpose I, so this is the column vector, its transpose is this. We are confining to 3 observations only, and the vector itself, I transpose I, and this we are going to apply the dot product or simple matrix multiplication. So 1 into 1 plus 1 into 1 plus 1 into 1, this is equals to 3, which is equivalent to the sample size because we have considered only 3 observations over here. So this is equals to I transpose I is equals to n, and let us see whether I transpose X will provide summation X or not. So let us take any arbitrary or hypothetical variable with 3 observations or n number of observations, so 4, 3, and 7. Let us calculate I transpose X. I transpose 1, 1, 1, and then it is 4, 3, 7. And let us see a simple multiplication. So 1 into 4 is 4, plus 1 into 3 is 3, plus 1 into 7 is 7. This is equals to 7 plus 3 plus 4 is equals to 14. And I transpose X. So this is actually the sum of our variable X. This is equals to summation X. So this is true. In matrix notation, I transpose X divided by I transpose I, this gives the mean of the variable X. Similarly, we can 1 divided by I transpose I can be written as I transpose I inverse. So let me also write it in a similar way. I transpose I inverse, and it is I transpose X, the vector X. And our OLS beta will explore this in our linear regression equation chapter, but now just to put it into the context. So let us see OLS beta estimate. This is equals to X transpose X inverse X transpose Y, where X is our independent variable and Y is our dependent variable. If we compare this relationship with this, then here our X becomes our dependent variable, and when we regress X on I, then the beta estimate, in this case, it should give us the average of this vector X. So this is it for this tutorial. Thank you very much. Thank you very much for your time. Econometrics Paladin.